Hey everyone, today we're sharing a presentation by our core team that goes over some helpful steps on how to develop on Pi. This includes a closer look at our core authentication and payments APIs, as well as how to clone and use our demo app, which is the fastest and simplest way to get started with our SDK. At Pi Network, accessibility is one of our core values. This means accessibility not only for pioneers, but also the growing Pi developer community building real apps and utilities. We're proud to boast one of the most accessible Web3 integrated developer platforms in the world. With our simple integrations, developers don't need any prior blockchain or crypto experience to get started. During this phase of the enclosed mainnet, one of our main focuses is building utility on Pi Network, supporting developers to build awesome applications that address real-life use cases and enrich the lives of pioneers. We hope you enjoy the video, and feel free to share this video with your developer friends and colleagues who may also be interested.
Our goal is to present an overview of the SDK and the APIs, which we call the Pi platform. And then we'll also give you an introduction to our demo application, which is essentially a boilerplate that could be used by you. If not, it can also be used to review for integration purposes, how to set your applications up. So to start, the Pi platform, it has two functionalities. The first functionality is connecting with a Pi user. And so the way we do this is through an access token. And this access token corresponds then to a user to be able to create a sign-in or to create a display utilizing this user's information. And then the second functionality is payment functionality. And so this is the ability at the moment to request a user to pay you or to pay the application in Pi. And that request will sync directly to their wallet, which we call the Pi wallet. And you'll be able to work them through the payment process in order to facilitate that. And for this first part, I'm going to go over what the user sees, and that way you get an understanding of how it works from a user perspective. And then Aurelian's going to walk you through the developer perspective on the back end after that. So we have here our demo app. And so this is the boilerplate I was talking about. And it is a Pi bakery, but on this demo app, we have a few Pis for sale, and we also have a sign-in, sign-out feature. And so the user sign-in is there, as I was mentioning earlier. It utilizes an access token. And so by simply clicking sign-in, this application will communicate with the Pi servers via the SDK that's been integrated into your application, and we'll obtain the user information. In this case, it's the username. And so you can see when there is no one signed in, there's no user information. And then once the user signed in, you can see the username there on the right. And to note, the user for this application needs to be signed in or authenticated in order to process payments. And that's because you need to have the user information in order to be able to process payments for that user. So now we'll begin the payment flow. And so I'm looking at the application, and I want to buy an apple pie. All I do as the user is I click order. And once I click order, then the payment flow changes. And so this screen pops up over top of your application. And this is the Pi wallet payment flow. And what this is controlled by the Pi platform, which allows security for the user when interacting with the applications. And so this is just an initial loading screen. There's nothing for the user to do here. Everything's being handled on the back end, which will be talked about in just a few moments. Once the payment is built and ready, then the user is displayed this screen. This is just a confirmation screen where the user can see all of the information that will go into the order or into the transaction. They can see here, okay, I clicked on buy an apple pie or order an apple pie. That was 3 test pie. So I can confirm that that is right. And I've got that my address is here as well. And I can see I'm ordering an apple pie. So I say, great, I hit pay with test pie. And now it brings me to the confirmation screen. And this is where blockchain comes into play. So on a blockchain, you have to have what's called the secret key or the passphrase in order to be able to approve a transaction. And so we need to collect that passphrase from the user. In the case of Pi, that's a 24-word string that is used to confirm the wallet address, which is the user saying, I agree to this transaction. Here is my passphrase to confirm my agreement. And this is a cryptographically secure and verifiable method in order to send transactions on the blockchain. And it is, from a brute force standpoint, extremely difficult to guess, if not impossible to guess these passphrases. And also at the same time, in order to protect this passphrase, because if it were to be collected by the developer could then process payments on behalf of the user without their consent. And so to protect that, this payment flow is a pop-up. As I was mentioning earlier, this payment flow is over top of your application. And so everything that takes place in this payment flow is inaccessible to your application, but it's okay. And so I look at this, I put in my passphrase. The user also has biometric ID options as well within the Pi wallet. So that's the image on the left. But I put my passphrase in, I click the pay button, and it'll now bring me back to another loading screen, which here, similar to the first loading screen, this loading screen is more actions being completed on the back end. Those actions are being completed by the Pi servers and by you, the developer. And once those actions are completed, then you'll see the payment results screen that's on the right. This has all of the information for the transaction there. So you can see I paid the 3 test Pi for the apple pie. It went to the Pi Bakery, which is our platform demo, and then the wallet address that it was sent to. So at this point, the user can click close, and the payment from a user standpoint has been completed. And so now I'll turn it over to Aurelian to talk about the payment flow from a developer standpoint.
Hey, yep, thanks for going through these. So the idea of the next few items that we're going to cover is going to be to kind of dive into what's going on when the UI shows what Christian was showing, and understand how that is built from the developer standpoint. So I guess one of the first things to say is that this is a design that is the reason this design exists is in order to get all parties involved to agree on what happened. So the idea is that the app front end shows the correct picture of what's going on to the user, the app backend and the app's database contain the right information. So for example, the user, the information that user X has ordered product Y and that they have paid for it. And then the Pi platform is kind of overseeing that entire process. Even though the blockchain is decentralized, there is a little bit of a centralized layer, which is also enabling the Pi platform to show some nice UI to the user, enabling them to remember why they paid for it and not just see a transaction in their wallet and they don't know where it went. And one of the things that we're trying to prevent here is if there's a bug somewhere, either on the Pi side or on the app side, we're trying to prevent users from double paying for the same thing. So we're trying to get everyone to confirm that they are aware of what's going on before the user makes the transaction and after the user has made the transaction, so that we never ever end up in a state where the user has paid for something, but nobody's aware of it. And now if they want whatever they're paying for, they have to pay again, and they ended up double paying. This is one of the challenges with blockchain. And the way we're solving it is with quote unquote simple tools, which are just JavaScript function calls and API calls, HTTP API calls. So no blockchain tech involved at this point. I think we can move to the next slide, please. So the process breaks down in 3 steps, which map pretty closely to what Christian was showing earlier. First is the app creates the payment. Then the app creates the payment. The user approves the payment and actually submits the blockchain transaction. And then step 3 is the payment gets completed, which is sort of another round of confirmation to make sure that everyone is aware that the payment has been made and that the transaction has been executed on the blockchain. So all of our involved parties are shown here again in a fancy, more organized way. And the step 1 is creating a payment, and that is done from the app's front end by the app front end calling a local method that doesn't even need to involve the backend to let the Pi platform know that this user needs to pay X Pi for something that they are trying to buy. So next step is the Pi platform responds saying, yep, I'm aware of what's going on. Here's a payment ID, and that payment ID will be the reference to this payment for the entire, for the rest of the entire process. Now, payment ID has to be recorded by the app backend, and as a way to prove that the app backend is aware of this payment ID and isn't going missing, the app's backend has to send it again to the app platform to confirm that it's aware of this payment ID. We're assuming that if the payment ID reaches the app backend, there is a very high likelihood that it has been correctly recorded in the app's database. This could obviously always, everything could always go wrong, but this is a mandatory step to at least know that it somehow reached the app backend, and then it gets sent to the app platform through a process that is called payment approval. Now, the next step is payment completion. The next step is payment completion, and this is where the user flow becomes interactive. This is where the user gets to either use Face ID or fingerprint or manually type their passphrase to sign the transaction. The transaction gets sent to the blockchain, which is the first arrow starting from the person's face icon on the slide. There is some interaction that is hidden under the hood between the Pi platform and the blockchain in order to pick up this transaction and know that it is linked with a given payment ID. And that is all handled by the Pi wallet and the platform, and none of it is the responsibility of the developer. Now, what happens is the Pi platform is going to return the blockchain transaction ID to the app's front end. And this is all happening on the front end side. Part of the reason being, as we said earlier, the user's passphrase never leaves their phone and never leaves their wallet app for obvious security reasons. So now the transaction ID is returned to the app's front end, and there is another round of sending it back through the backend in order to, once again, kind of prove that the transaction ID has been received and that there is a good chance the whatever goods will be delivered. And so this transaction ID has to be sent somehow by the app's front end back to the app backend, and the app backend has to send it again to the Pi platform. through the process that we call server-side completion. Now, on the next slide, we are linking all of these concepts with technical terms that are used in our documentation and that are the actual function names and API endpoints that will have to be called in order to implement this. So number one, to create the payment is an SDK method. SDK meaning the front-end JavaScript library that gets integrated into the app front-end. And the app front-end calls a method that's called create payment. And create payment takes a few JavaScript callbacks. So kind of small methods that are used to handle events happening on the payment. And those two events are onReady for server approval. And this is when we get the payment ID that we need to send back to our backend for the server-side approval step. The REST API endpoint that is used for this purpose is payment/payment ID/approve. And then the whole part where the user interaction is needed is completely out of the developer's plate. And when we get to the next event that the developer needs to handle, which is onReady for server completion, this callback is called by the app platform with a TXID that we then have to send to our backend as a developer and gets posted to the REST API endpoint called payment/TXID/complete. That's it on the tech stuff, or on the specific implementation details.
So I know we've thrown a lot of information at you, and I want to give you some resources that you can utilize to review some of these things. And so mindpy.com/students is the URL that you can visit that has links to a lot of these resources we've either been showing you as the presentations on there. We also have links to our demo app repository, which is on GitHub on that page as well. And then there is some more in-depth documentation there also that is linked. So utilize that URL for obtaining a lot of information that we spoke about here. If you haven't already, please download the mobile applications. There are links on that website. You will need the mobile applications to be able to develop on Pi. But for the last part here, I would like to go over the demo app, and I'm actually going to skip ahead a little bit, and I'm going to talk directly about the demo app, and I'm going to show you some of the functionality of the demo app. That way you can get familiar with it. So like I said, you can head to the repository, which is linked online. Great. So I've got an instance here on my local machine of the app code. And as you can see, I've already got it running. And there's something we call the Pi sandbox. And you can see here the URL is I'm running this on localhost. However, when I come in to do anything, it's not going to have any functionality. And that's because the application is not connected to the Pi SDK. So to connect to the Pi SDK, when you're on your local machine, you need to log into the sandbox. And you'll be able to do this from within the application. You'll get a URL. So this URL here points to this application. And so you can copy that out of the developer portal, and there's instructions on how to do that on the demo app repository. But once you copy and paste that URL that you're going to get out of the application, it's going to bring you to the sign-in screen. You're then going to enter the code that's shown on this screen in your Pi app, and it's going to confirm it. So give me just one moment here to type it in. And it should redirect. Excellent. So once you are able to confirm the sandbox within the Pi app, it then loads the application in this window. And now you'll be able to not only see the application, but you'll also be able to interact with it. So we can sign in. You can see I'm signed in now, and then I can process a payment. And I'm not going to put my passphrase in here, but if we go through, then the payment will process. Cancel that. But now to go over a little bit of the functionality that Aurelian mentioned, and those authenticate functions and then the create payment functions. This is the demo app code, and you can come in and you can see how we've laid everything out. Or, as I said earlier, you can use it as a boilerplate. So the first step to integrating the SDK in any of your applications is going to be to plug in a few script tags into your index.html file. And so that's here, line 43, I'm going to highlight it, to 54. So the first script tag, which is here on line 44, this is the URL that connects to our SDK. And then you also have to call this Pi init function. And what the Pi init function does is that is going to tell us what version of the SDK do you want to connect to. This will make it backwards compatible should we make any updates to it in the future. And then also it has this sandbox flag. And the sandbox flag is what I just showed you in that when you select, or sorry, when you set the sandbox Boolean to true, it is going to deploy into the sandbox mode, which means you can access it on your local environment. So very important that you plug those two script tags into your index.html file to get started. And then the other functions that come from the SDK, the first one here is the sign. In the application, it's called sign in. On our documentation, it's called authenticate or authentication. And so it has a few inputs. It has the scopes input, which you can kind of select the information that you want to get out of it. And then you plug it into the header, and it's going to have a callback function into it as well. And this callback function is what the incomplete payment found is part of the payment functionality, which I'll explain in just a minute. But you're going to call this authenticate function, and that's going to be what gets that access token, which gets you the user information. And so you can see here that we've added a few extra things into this original call. This is just to create the, this is to sign the user into the application, but then also to display their username. But for base functionality, you just need these two lines here, which is what you're going to use to get that access token. And so once your user signed in, now you want to process a payment. There is a number of different payment functionality, but most of them are callback functions, the callback functions that we went over. But the way to create a payment is here on line 96. We've got the create payment, which is coming from the Pi SDK. And that takes two inputs. It takes the payment data and the callbacks. The payment data is things like amount. There's memo metadata. So you can add extra information to your payment. It's not limited to just having a Pi amount. You can add different things to it, whether it's, in the demo app instance, this is for ordering from the Pi bakery, or this is order number 1, 2, 3, 4. So you can add various things into the payment.
And if I may add something here, this is actually required, and this should or must be used in order to understand what this payment is about. If the only thing that's left is this metadata, this needs to enable recovering what this payment is about. So it could be an item ID, it could be an order ID, a cart ID. an NFT, an NFT ID that this user is about to buy. It can be pretty much anything, but it has to be able to, it has to enable recovering what this user was paying for. This is required, and that's why it is. It can be used to store any metadata we want, but most importantly, it must be used to enable recovering what this payment is for.
And so likewise, the callbacks are also required. The callbacks are what enables the process, the payment process, to move along. So as Aurelian was saying in the payment explanation, once you send this create payment function, then everything else is kind of handled asynchronously as it comes through. And so these callback functions are all the functionality to handle the various steps within the payment process. And you'll see here, they have very similar names to what was used. So on ready for server approval. This is that server side approval. This is that first part of creating a payment. Then we have on ready for server completion, which is the second part, which was the server side completion, payment completion functionality. And each callback function is defined just below on these parts here. And at a base level, what this is doing, this is telling your application what steps to complete when this callback is called, when this callback is made. And so it receives the information from the SDK. In this instance, it takes the information, so either the payment ID or the payment ID, the transaction ID, and it's sending that information to the back end of the application. And once the information is received on the back end, then that information is able to be sent and either approved or completed utilizing the Pi APIs. And I'm not going to go over how to implement the APIs in this step. They're laid out on our information online, but they are a REST API, which utilizing an API key, you can call the endpoint, pass in the information that is requested, and it'll complete that step of the transaction. And so this is all of the code on the front end required to process a transaction and integrate with the SDK.